today's lecture discussion. Right. So we are starting this last chapter of this course today, right? And it will be continue for the next at least four lectures or maybe five lectures, right? And from now we will be engaging this discussion naturally on the lecture note basis, and I will be posting some of the assignments also. Assignments related to this topic, related to this chapter, right? So now, as we are in the last part of the syllabus of database system, so primarily this last portion of the syllabus is considered as a basically the whole story, because in the earlier classes, in the initial classes, we have discussed how to model the database. So modeling database means so if requirements are given, any real world requirements for the system are given, for those requirements you can have a basic understanding about the database, that this is how a database will be modeled, or this is how the database will be designed or created. So based on those requirements, in the very first step we have created the model of the database, right? And we refer that as a conceptual model of the database. So that phase is called conceptual modeling. After that, we have gone to the second phase, which is called logical modeling, or maybe it is a simple map of a conceptual model into the logical entities or logical model of the database. So during that phase, we have simply created the mapping of the conceptual data model into the logical entities model, like actual database tables, which we have created or which we have identified, right? And along with it, we have created these database entities or database table into the actual system, into the actual systems uh, boundary, right? So that is something we have discussed in the first phase. After that, in the second phase or second part of syllabus, we have taken the discussion on how to design the data. I mean, because we have created the database, and on each database we used to upload the data values, data entry. Now that data entries which we have uploaded in the database, you cannot directly perform some operation on it, because whenever we are going for this kind of uh, database arranged for the user, whenever user is operating on that database, it might create lot of bottleneck, particularly for the performance, right? Particularly for the concurrent access of the data. So that's why we have performed this concept called data design theory. So on that, we have taken the concept of normalization. So normalization is one strategy, one type of strategy through which we can make our database efficient. It is basically having no problem, no bottleneck issues as far as users operation concerned, right? So after performing this data design or the normalization, particularly on the database, you can claim that my data or my database is available for each kind of access. Like, you can have single user access on the data object and data value, you can have multiple access or multiple user access on the data value at the same time, right? So that is something, basically this normalization theory basically ensures that your database is ready for multiple multi-user concurrent access on the same data. So like, you can have access, you can ensure that on a single data value multiple users can access at the same time, right? That is something we wanted to achieve, because eventually whenever we are designing a database system, it is the objective that my database system will be uh, available, and it will be efficiently working for any number of users at any point of time, right? So that is something we are basically aiming for. So whenever we are designing a database system, whenever we are designing a database for any big picture system, big picture software, your objective should be like your backend will be supporting these concurrent, these parallel, these sequential or subsequent accesses of the database item or database object at any point of time, right? So that's why now we are going to have this specific discussion on the concept called transactions, right? So when I say this transaction, uh, whenever I raise, I'm raising this term called transaction. What is the transaction? Can you tell me what the transaction means? Because till now we have taken the concept called operation, function, queries, commands, all these things. So what do you mean by transaction? Can you tell me that, so that we can continue the discussion? So you can post your replies on the chat box. Meantime, I am sharing the classroom notes of today's lecture. So let's understand what is the transaction mean, right? So yeah, that's the next objective of the chapters, that right. So yeah, so I think it is this screen is visible to you. So I can see these notes. So this is our 25th lecture, and the topic is now, upcoming topic will be transaction processing theory and technique. So basically that's what I have underlined. So in the first phase we have taken on the data modeling, then we have gone for data design theory. That's what we have taken as the first two steps, or first two levels, or first two phases of database system design, right? Now we are going for the next part, which basically says, which basically talk about the user operation, directly user operation, right? So whenever I am saying user operation, right, so whatever we have discussed till now, it is in the form of query, it is in the form of system operation, how our DBMS is doing or operating on a particular occurrence of a particular operation, right? So whenever we are thinking of real-time presence of your system or real-time presence of your data, it is always with respect to the user operation, that what are the user operation user will be submitting on this database, right? So whenever we are saying that, okay, user will be accessing his account details, user will be accessing his amount of money available in his account, user will be accessing the number of seats available for a particular source destination within trains, user is accessing some details about the possible list of available flights or their seats. So these kind of operation we are assuming in the real life, and each operation of user, each action of user on the database system will be considered as a transaction, right? So like in our case, we used to go into the IRCT system and we used to log in, then we used to inquire the possible list of trains available between the source and destination. That's one single transaction, because he's simply reading, he's simply performing some data request, he's simply retrieving some data and values, right? So we can have similar other operation also. So based on his request for the possible trains, he can further extend that transaction, further extend that operation into a booking of a ticket transaction. So your transaction becomes a write operation, because you will be updating some values, right? So broadly, in the life of a database, there are two possible types of operation, user operation. We assume first is the read operation. Read operations typically is nothing but it is a simple read. I mean, it is simple request for retrieving the data. But in case of write operation, you will be naturally reading the data and then updating the data values also, right? So write involves some kind of manipulation, but in case of read operation, you are going to only retrieve the data, retrieval with the purpose of reading it, accessing it. That's it, right? So whenever we say it is a user operation, it means it will be initiated by the user. That is for sure. That is one part. Second, it will be involving various users interaction, users request on the data value, right? So each data user operation will be naturally going to read some detail about a particular cell, particular record, like whenever we are discussing SQL. In a SQL, it is like it is accessing tuples or attributes or specific values. But in case of user operation, it is dealing with some data value. Like in the typical case of IRCTC, we used to go to the IRCTC website, then we used to enter some pair of source and destination station and provide the data of journey, and based on that, system is retrieving the possible list of trains, and then possible seats of available seats for each specific category for a specific train. So it is again retrieving the details of trains and the respective categories of seats, then possible dates of availability also. So it is again combining the data values from the multiple tables, and it is displaying these details to the user end or user interface, right? So this is a typical operation of read, you can say. In the second scenario, if you select one particular train and one particular category, it will be going to have some intermediate step involved, and eventually at the end it will be updating the seats, because for each transaction you will be asking for some manipulations. Like if you go for 2 seats, booking for 2 seats, these 2 seats will be deducted from the existing number of available seats to a particular train, right? So at the end of each write operation, we will be updating one or two data values in the database system, right? So like in the case of ticket booking in the IRCTC scenario, we are simply deducting the number of seats available, and we are creating new record into the table of PNR, because for each ticket booking a PNR number is generated, a passenger detail has been saved. So whenever we are performing write operation, it leads to the manipulation of one or two values. It needs to the addition of some values. It needs to the deletion of some values also. So like in case of ticket cancellation, so ticket cancellation again is a write operation, because for that operation, ticket cancellation, it will be going to free those booked seats. That is one part, and it will be basically making this PNR number as a null, or maybe erasing it from the record, right? So for each write operation, because for any real-time system, we will be performing some user operation, and for these user operation, we will be doing some manipulation on the data value, one or two data values, right? So like in our initial discussion, we have taken this concept called different types of user on the database. So now you can correlate these operations, that for each different type of database user, we have different read and write operation on the same database. These 3 different types of database user will be performing 3 different read and write operation, right? It is not like that there is a specific set of write operation defined for all these 3 types of users. There are 3 different types of users on the database, and these 3 different database users will be conducting different types of read operation, different types of write operations, right? And conceptually or theoretically, these user operations are considered as a transactions, right? So transaction is a big term. I mean, it is not a simple term like that. So whenever we say user will be going to perform some operation, user will be performing some kind of read and write instruction on the top of database, right? So one thing is very important. Whenever as a user I am going to perform some operation on IRCTC or maybe SBI, so whenever you are performing a read operation, right? So read operation, okay, so just because of any external reason, if that operation fails, there is no issue, right? So whenever we are simply reading a data value in the database, if because of some external reason or maybe some internal reason or maybe because of any reason, if that operation fails, if that operation interrupted by some reasons and fails, it is interrupted, there is no issue with that, because we are not manipulating it, right? We are not changing the value of the data. But in case of write operation, in the occurrence of write operation, if that operation fails, if that operation interrupted by some external reasons, it will create lot of invalid data values, lot of inconsistent data value, right? So that's why it is important to have some kind of mechanism which will make sure that because of interrupts, because of failures of a transaction, failure of operations which involve particularly read write operation, you need to provide some kind of backtracking, revert, or maybe reinstate kind of mechanism, right? You cannot leave that data value partially manipulated or in the inconsistent state. So for instance, you are transferring some amount from your bank account to your parents or your family members account, and due to this external failures of external reason of failures, your transaction has been failed or interrupted. In that case, it is principally desired to revert these transactions, all those transactions which have manipulations involved, and it has failed due to some reasons, then it should be reverted, it should be backtracked, it should be reinstated into its original state, to the initial stage, right? So state of data, the state of data which we have started with, right? So whatever amount you have initiated as a transfer amount, it should be revert back to your account. That is one state. Second state, it will be like whatever operation you have intended, you have started, it should be completing. So this amount should be transferring to the next account which you have submitted, right? So these are the two states which we are saying as a valid state, right? Because that's what you are tending to. जो आपने assume किया था कि ये टास्क, ये ऑपरेशन होना चाहिए डेटा आइटम पे, या तो वो अमाउंट जो आपने स्टार्ट किया था ट्रांजेक्शन के लिए वो या तो रिवर्ट होकर आपके अकाउंट में एज इट इज आ जाता है, या तो वो कंप्लीट हो जाता है, मींस द अमाउंट हैज बीन ट्रांसफर्ड टू द नेक्स्ट अकाउंट व्हिच यू हैव फिल्ड ऑन इट, राइट? सो अगर ऐसा नहीं होता है, देन ओनली वी कैन से दिस ट्रांजेक्शन इज not completed in its boundaries. So whenever we say there is a transaction, so transaction term means naturally there is this user operation aspect involved, that user is trying to perform some operation on the data items, data values. Now the second property of transaction term is says whenever we are performing these user operations should be performed into complete boundaries, जहां से स्टार्ट हुआ उसके बाद लास्ट तक. So it is like end to end completion. If there is a external interruption happen between the transaction boundary, this start to end, so if there is any interruption in the transaction happened, then the system should be able enough to either complete this transaction by somehow, or it should simply revert to its initial state, right? And this is something very important, and this is the responsibility of DBMS. There are various components available in the DBMS system, DBMS software, which takes care about these things, which takes care about these principal responsibility, that transaction should be completed into its boundaries, right? So with this description or with this definition, you can read out these instructions like transaction is principally called logical unit of database processing. Logical unit means whenever we talk about what is the database processing, what is the capacity of database processing, we used to say that my database is able to perform 1,000 transaction in a minute, 1,000 transaction in an hour, right? Like if you can you tell me one thing, what is the possible limit of number of tickets generated by IRCTC? Can you tell me any guess? So what is the maximum capacity of IRCTC system? So that will be the transaction, that will be the logic units, that IRCTC system, which is again a transaction processing system, which is again having some database, it will have some number of unit operation limit that it can generate, or it can book the ticket of around, maybe let's take example that IRCTC system can book 9,000 tickets per hour, per minute, something like that, right? And this limit is higher during this tatkal booking time. So let's take between 10 a.m. to 12 p.m. This IRCTC system is able to book around 9,000 tickets per hour, something like that. So that will be the logical unit, right? So transaction is something you can use to identify your database, that my database is able to generate or process these number of transactions, these number of operations, right? So transaction means a logical unit to indicate the capacity of the system, right? Like my database system is able to generate these many logical operations, these many transaction operations, right? So whenever we say transaction, it may involve access for the database. So transaction includes one or more database access. So access means it is about reading. So for any transaction, any user operation transaction, you will be accessing one or more database values or database value set, right? That is for sure. And naturally, in these operation, we are expecting that there are various operations like insertion of records, deletion of records, modification of records, or simply retrieval, right? So these are the three primary types, you can say. These are the three primary operations which will be performed within the database, under the database, right, for the user operation. That is for sure. Second thing, you can understand that these database operation that form a transaction can either by some API based systems also, or maybe they are coming directly from the SQL. So that's what is the perception, right? In the case of IRCT systems, we are performing some high end or application based programs defined, through which we are performing some operation as a user, and these operations are mapped into the transaction on the middle level, and then eventually it will perform something on the database or data physical level. Similarly, you can perform directly a SQL query. So likely, typically as a programmer, we have performed a lot of queries. So for each query, there are this transaction performed on the bottom of the system, right? So these operations, database operations of the users, will be submitted either through some API, some GUI, or it may be directly coming from the SQL query also, right? So these two types of database operations are simply represented as a read-only transactions, and second one is called read and write transaction. So write transaction is typically called read and write, and read only means you are simply accessing it. You do not have any intention to update the database object or database value, right? So these are the two only possible type of operation we used to have in the database as a part of transaction, right? So this is the complete definition or complete description of a transaction. Term transaction is called, right? So you can see here it is said so a transaction which is used to represent a logical unit of database processing. That's the first point we have discussed. Then that must be completed in its entirety to ensure correctness. Entirety means it should be completed in its boundaries, right? So boundaries means the starting point and the last point. So if transaction is started, if you have started a transaction, then then from this point, start point, to the last point means the point which you are expecting. That suppose you are transferring some amount of money to your family members, then this transaction assume that the amount has been transferred to the next account number. So that is the second boundary. So whenever we initiate a transaction, it should complete from this boundary to this boundary. Then only we consider that this is a completed or successfully happened or executed transaction is, right? That's the typical. So whenever I say what is transaction, whenever I say there is a transaction involved, whenever you say, okay, my transaction has failed, whenever I say the transaction is completed, so you should have these two impressions about that. First impression is that it will have read or write operation involved. Second is it will be completed, or it should be completed within this with boundaries of the transaction, with its entirety of the life, right? And is to ensure the correctness. So that's why we are discussing about, right? Because if we fail to complete the transaction, these values will be becoming incorrect. If your system is not able to complete it to the any boundary, then these values on which we have performed manipulation will become incorrect, right? Invalid, right? So primarily, if we see these read and write operation, so read item means it is a read operation which simply reads a database item named X into a programmer. So it is basically reading a data value. That's what the read operation X. So here X is a data value which you are trying to read. Similarly, for the next write operation, it will be like it is the It is a writing or manipulation of a particular program value X, right? That's a simple representation is. That's what we are taking again and again. Now with this basic definition and basic impression of database transaction processing, you can say we have in the real life, on the real world, there are many systems which are supporting these kind of transaction support, transaction processing for the huge number of users, right? Like one of the best example in Indian scenario is this case of Indian Railways ticket booking system. So they are providing this huge database related to the different trains, related to different routes and paths, related to different categories of seats booking for a particular train, different categories for a passenger within certain class, like you can have senior citizens, for women, something so there are various categories within a particular train. So this huge database is available for this millions of users, right? And millions of users are operating on these huge number of data available into this single database. On these different or these millions of users are accessing these hundred of data values concurrently. They are accessing these data values and they are performing some kind of read and write operation concurrently. That's something very important. Concurrently, so hundreds of users concurrently accessing these data values, right? And that is something is a challenge, right? You need to have some kind of mechanism to ensure that no transaction will be failing, no transaction will be basically creating an invalid state, right? Because suppose one transaction has created this invalid state of value, some due to some transaction failure of a user, if particular train got invalid state of available seats, then the upcoming users will be misled by that value. It will again create another invalid state of available seats of values. So one transaction, failure of one transaction may leads to the failure of various forthcoming operations, forthcoming transactions on the data value. So that's why whenever a data is available to hundreds of or millions of users for concurrent access, it is the responsibility of DBMS system or the component of DBMS system should take care about all these transactions and its completeness, right? So this is the typical nature, and that this is the challenge which we are going to discuss in the upcoming 2 or 3 or 4 lectures, that how to achieve a database or database processing system which can efficiently process these concurrent access on a particular data value without conflicting any subsequent or any parallel transaction on the same database, right? So that is the reason, that's why we are getting this impression. So whenever we go to the IRCT system, whenever we go to the any such kind of systems where huge amount of users are engaged or logged into, we do not have any interference from the other subsequent user. So like in IRCT system, if you go between 10 to 12 window in the morning, there are hundreds of users has been logged into the system. So it is the responsibility of database processing system to create an impression that you cannot have this impression that there is other users are also accessing the data value, the same data value which you are trying to access, right? And that is something is the responsibility of database processing system, transaction processing system, right? And it is happening because of there is a component placed in the DBMS which is taking care of this isolation property, that you will be able to perform your transaction without any interference from the other concurrent, other subsequent, or other neighboring users on the database, right? So each and every user who is trying to access data item will have this kind of isolation, isolation feeling that there is only one user, that is me, who is accessing the database value. right? So these things are basically the principal role of, these are coming because of there is a component placed in the DBMS which is taking care of all these property, right? And that's why we are getting nowadays, we are getting this system very in a very efficient or very you can say basically reliable systems which are creating a transaction in its valid state, and it is not creating any invalid or inefficient access to the database values or data values, right? So you can see there are various examples available. These are few listed, like we can have airline reservation systems. For that purpose, we have banking, credit card processing, online retail purchasing, like in Amazon and Flipkart scenario. Stock markets are there. Then we have supermarket checkout and many other applications which are available, which are following these nature of transaction processing, which are considered as a transaction processing system, because they are directly providing the mechanism to access the data values from the for on the behalf of user operation. Similarly, there are two or three main properties. The first two properties are like it should be highly available, right? So whenever we are thinking about these kind of system, transaction processing system, it should be highly available, means it should be available for the largest number of users, right? And it should be responsive enough. It should be having high response time for each and every user, and that is what the minimum expectation is. So whenever we go to the airline reservation, whenever we go to the IRCTC system, these two are the expectation we have with the system. That system will be basically it is available for any time or any point of day of the day, any point of day of the year, and it should be available for 24/7 duration. And whenever I am going to access that system, it should be fast enough to respond to my operations, right? And that is for the all of the users. So any point of time, hundreds of users can interact, hundreds of users can access, and it should be responsive enough, right? So with this, let's go to understand that. So whenever a transaction is happening in the system, what are the different possible states? What are the possible stages of a transaction, right? So this typical state diagram basically explains that different state of a transaction, right? So you can see it, and you can see that what is these are the obvious terms which we are going to discuss, and these are the terms which we used to listen that, okay, whenever I'm going to ATM, I go to ATM, or I go to any terminal based operations, or maybe window also, banking window also, I used to hear these kind of terminologies, right? So typically the first state is active state. So whenever we go to ATM, whenever we initialize some transaction, after providing the pin code and few choices, we start reading some data value, and that is happening in the active state. So whenever you are doing some operation, whenever you are applying some value, like suppose you are entering the amount value which you are going to withdraw, so that's your transaction in the active state. Whenever you are, like in the case of train ticket booking, whenever you are supplying uh, we are supplying some passenger details, you are selecting certain choice for the category, you are supplying some information for the transaction, your transaction is in the state of active, right? Because the transaction is active, you are supplying some information, you are submitting some application, some information for the transaction, and its initial boundary, your state for the transaction is active, right? So after completing the first state, after submitting all the information to the transaction, after submitting all variable values, variable information into the transaction, your transaction is completed, your operation is completed basically. So whenever user operation is completed, your transaction goes to the partially completed stage. So this after active state, ideally the next stage is called partially committed. So partially committed means whatever changes you have done to the particular data value, particular the data item, particular data which is like suppose you have requested for the amount transfer to the your family members account transfer. So the amount which you have in the, like, okay, 10,000 में से 5,000 transfer करना है. So after this, once you submit, okay, 5,000 should be transferred, submit or okay, your transaction will be going to this active state to partially committed, because whatever changes you have requested on your amount detail, whatever number of tickets you have requested for, that change has been partially completed, and it will be going to the next stage, which is called commit. Commit means it is permanently deducted. It is deducted from your account, and it is transferred to the uh, second account. That amount you have requested is now transferred to. So once transaction is reached to this point called committed, all the changes on the behalf of your transaction is being completed, right, and achieved completed and reflected completely. And then last stage is called terminated, means your transaction is basically achieved, and it is saved, it is completed, right? There is no point open for that. Now after this, so this is the typical best case scenario, that there is no external interference happen to your transaction, like from beginning a transaction to perform some operation during active state, then you can go for partially committed. Then after partially committing, partially saving, you can go for, I mean, system is taking this transaction into the committed state. After committing, you can go for termination. So this is the typical best case scenario. Now you can see that there is a abort failed state, right? There is a state of transaction which we are saying is a failed, right? So that the first scenario for transaction to a failed transaction is called or due to any external interference or any external or internal failures during these user operations. So suppose you are simply after logging into, or maybe after this submitting the initial credentials, if you go to the ATM after supplying the password and other things, you have externally cancelled it, or you have externally aborted it. That is one way. Similarly, for the in IRCTC scenario, if after selecting certain train or certain category, if you have incorrectly clicked on somewhere or incorrectly supplied some value, or maybe internet failure happens, that is something external. So immediately that transaction, so you have just started performing something related to your task or related to your action, but there is some externally happened, there is something unnormally happened, then you simply cancel it, or maybe system cancelled that transaction. Then this transaction goes to active to failed state, and it is called abort. You're simply interrupting, or you are accidentally closing it. So that state of transaction now becomes from active to failed. Similarly, if you have completed the transaction successfully, you have done your task and you have simply completed your operation, and this transaction is going from active to partially committed. So if some changes has been happened because of your transaction, and these changes are partially saved, and transaction is in the partially saved state, but because of some uninterrupted reasons, these systems saved partial values has been lost, this system saved value has been destroyed, then DBM system will take care about this failure, and it will declare that transaction which we have initiated and transaction which we have assumed that it is now in the partially committed state, it will be aborted immediately, and it will be considered as a failed transaction, and then eventually after failed state, it will go to the terminated stage, right? These are the five possible states: active, partially committed, then terminated, and failed, right? So we have five state theory, or five possible states for a transaction, for a user transaction, right? And DBMS system, there is a designated or dedicated DBMS component available to take care of each and every state of these transactions, right? And in the database processing, each and every transaction will be going through these five states, right? These five states. And if DBMS system assume that there is something wrong with any operation, it will simply terminate it, or it will simply abort it, and based on that, it will perform these backtracking or revert back operations, right? So with this, you can see now, so these are the possible five states of a database transaction. And now you can see So along with the read and write, there are other operations are of defined for a database transaction. So you can typically read it, and these are two common sense based instructions, right? So whenever we have a transaction, these are the possible points which we could have, right? So there is a point which is called begin transaction. So whenever we are simply, so you can say in the ISCTC, whenever we logged in into the system, it is the begin transaction. So at the moment when you log into the IRCTC system, at the moment when we insert our ATM in the ATM machines, it is the begin transaction time, right? So after that, after beginning or after doing some validation, authentication, uh, there is a various instruction related to read or write, right? So after begin transaction time, all the instructions which is performed by user related to reading some value, related to writing some value are there. And after this read or write and all things, there will be in transaction also. So in the transaction indicates that whatever task you are doing has been completed. So right, so you can say in the transaction state is a state. After that, we can assume that database transaction is in the partially committed stage. So after in the transaction, once the transaction reaches to in the transaction stage, you can claim that the after this point, after this in transaction point, this transaction is in the state of partially committed, right? All the changes which you have done, which you have performed, are being saved partially or temporarily in the in some kind of storage, some kind of buffers. After this there is a point called commit transaction. In the transactions life itself, there is a point called commit transaction. So we have this in transaction point. After this in transaction point, there is a time slice available, there is a lifetime available, which refer as a partially committed stage. And once this transaction reached to this point called commit transaction, each and every changes which we have reached, which we have initialized because of our operation, is being saved permanently. Once your transaction reach to this commit of transaction point, each and every changes which we have raised will be saved permanently, right? So that is something fourth operation or fourth uh, signal of that. Now after that, there is the operation called rollback or abort. So we have seen in the state diagram also, there are two possibilities of abort. So abort means what? Abort means rollback. So whenever we realize that there is something happened, maybe between this, before this in transaction state, or maybe between this in transaction to commit state. So between these two possible spaces, between these two lifetimes, there is a possibility of abortion of particular transaction. So in that case, you need to decide that how much I am going to roll back, right? So these are the 5 operations possible. So operations means within our transaction, these are the possible information available. These are the possible, you can say that, in our lives, because we have different milestones. So you can refer them as a milestones of a transaction, you can say something like that for a better reference. Yeah. So so these are the 5 milestones we have in our transaction. So actually, our database management software is taking care about these different these 5 milestones, because each and every milestone will serve some purpose, right? Right, that's what we have discussed. Like in case of any transaction, anything which happens after in the transaction will be saved temporarily. And if transaction reach to the commit transaction point, commit transaction stage, that transaction is permanently saved. So whenever a transaction is failing, whenever transaction is aborted by some reasons, it will look for these possible entries कि जो आपका ट्रांजेक्शन था उसमें कौन कौन से इंस्ट्रक्शन हो चुके थे, बिगन टाइम क्या था, रीड राइट ऑपरेशन कौन सा किस टाइम पे हुआ, इन ट्रांजेक्शन का टाइम क्या था, और इन ट्रांजेक्शन और कमिट के बीच में क्या टाइम था, क्या एग्जैक्टली टाइम वैल्यू क्या थी. So if something's happened between that, based on that only they can perform rollback, right? सो अगर वो इनिशियली एक्टिव स्टेट में ही फेल हो गया तो आपको रोल बैक कुछ नहीं करना, क्योंकि अगर एक्टिव स्टेट में ही ट्रांजेक्शन फेल हो गया तो कुछ भी हमने पार्शली सेव नहीं किया, तो यू डू नॉट नीड टू परफॉर्म एनी रोल बैक, राइट। बट इफ समथिंग हैपेंस ड्यूरिंग द पार्शली कंप्लीटेड स्टेज, तो आपको जो रोल बैक करना है, अगर पार्शली कंप्लीटेड स्टेज में थे उस टाइम सिस्टम फेल हुआ, तो जो आपने पार्शली सेव किया चेंज उसको रिवर्ट बैक करना पड़ेगा, समथिंग लाइक दैट. So that's why each and every operation is important, and their time value is important, time stamp is important, right? So anything which is happening in the transition point of view will attached with this value called timestamp. Timestamp is basically the information of the transaction, time information, temporal information about the transaction. Nowadays, just because we are having these transaction operation for the across so for the global user in different systems, so keeping this timestamp information will not be sufficient. So that's why in nowadays these transactions processing systems are keeping track of the geographical information also. So that's why in one of the lectures we have pointed out that whenever we say a system is a real world system, real time system, it means it will be operating on real time value and real geographical value concern, right? So whenever we are taking care about the time value of the operation, nowadays it is important to capture the geographical value also, that this transaction is performed at this time and this location, this geographical location, right? So that's why it is important. So each and every these 5 operations will be used to complete or to perform the operation, right? So that's it for the today's lecture. Now in the upcoming class we will be discussing, on the next lecture with the class, we will be discussing uh, these possible points, possible reasons of failures of a transaction. That's one part. Why systems are, why system is assuming that okay, there might be some failures, there might be some external reasons due to which a transaction can fail or may fail. So we will be discussing these reasons for failure maybe in the tomorrow lecture, and beyond along with it we will be discussing a very interesting concept called conflict, right? Conflict means suppose more than one user is accessing the same data value at the same time for the different operation, how system is taking care about this conflict, right? So suppose 2 users are trying to access a same data value, and because of some external reasons, if something happens, how system will be ensuring that the other user will not be get affected, right? So these all possible things we will be discussing in the tomorrow lecture. So if you have any doubt related